Welcome to episode 7 of Simulating Nature in Scilab. This is food safety. We are going to model the growth of bacteria in warming food. This particular food and bacteria were familiar on the long-dead planet of Xi'an. In other words, no actual instruction about human health is taking place here. What is involved in food safety? In other words, what accounts do we need? We have the increasing temperature of our warming food. In this case, a kind of poultry roasting in an oven. Food temperature is our first account. Our second account is total bacterial activity and thus contamination in the warming food. Our dependency sentences. Bacteria growth rate is dependent on bacteria colony size, but the idealized growth rate is trimmed by food temperature. Food temperature growth rate is dependent on the difference between food temperature and oven temperature. Let's identify the parts of our model. The star of the show is our account containing total bacterial activity. This is the growth loop where peak growth can be trimmed if temperature isn't ideal. The trim factor, from 0 up to 1, comes out at the lookup table. The input to the lookup table is the other account, food temperature. Here is our warm-up circuit for the roasting food. Food temperature tries to catch up with oven temperature. More quickly at first, more slowly later. The food starts at 38 degrees Fahrenheit, fridge temperature, heading towards 350 degrees Fahrenheit. At 38 degrees Fahrenheit, bacteria growth efficiency is a tiny fraction of what it is at 100 degrees Fahrenheit. The lookup table kicks out this tiny fraction of 1. When the food is well above ideal temperature, in the 130-degree range, growth stops, bugs are dying. How do we make our warm-up circuit work? We test to see how far below oven temperature the food is by subtraction. That difference, which becomes less over time, drives our food temperature change rate and thus food temperature. We throw in a scaling block for food warming efficiency. This incorporates how the oven air behaves near the food. Does it circulate well or just stick to the side of the food and split the difference in temperature, slowing cooking? Although the food warms from fridge temp toward 350, we will take the food out of the oven at around 180 F. Preparing to run version 1. Let's check our starting values. We start the food with 1000 bacteria. We check the contents of our lookup table. 0.01 down low. 1 times in the middle where temperatures are ideal, and 0 up high where life is becoming impossible. Over a 4-hour roast, our food warms in a gentle curve. A bit faster during hour 1 than later. The middle graph shows when, over time, our bacteria colony was dividing at slow speed, half speed, and full speed. The full speed plateau reflects when the food was around 100 F. The bottom graph is total colony development over time. Under 1 hour of cooking time there is very little colony increase. This is because lower temperatures and not very many organisms yet combine to keep the total low. Starting at about hour 1, bacteria colony growth explodes as more and more organisms combine with optimum temperatures and colony size rockets up above 15,000 organisms. As food temp continues up, the colony is under stress from higher temperatures and current growth is shutting down. By 2.5 hours there are no more viable organisms, above 130 F, and the bottom graph has stopped climbing at around 16,000. This is how the food is served and eaten. The Xi'aners were sensitive to live bacteria but also to leftover materials from bacterial life cycles. Our 16,000 final account level reflects the total amount of contamination from 16,000 bacteria lives lived. Are there any options to get the final bacteria contamination level down? Yes. Heat the food faster. We want to leave the oven temp at 350 to keep from burning the outside of the food. Lots of modern ovens have a convection fan and we are going to turn it on in our oven. We do this by changing the gain in front of the food temperature account. We increase it from 0.15 to 0.25. This represents reducing a small sticky boundary layer of air right next to the food. Here are our graphs for run 2. Convection on. The top graph shows us finishing the food in about 2.5 hours. Much better. The Zienners drink less grog waiting for dinner. The middle graph spends less time in the optimum growth temperature range for our bacteria. The bottom graph shows a much lower contamination level in the food cooked the second way. Metabolic products from only around 5,000 lives lived. Bon appetit! Starting next episode, we work with cascaded accounts, like stations on a pipeline or assembly line. See you next time for 2VAT Flow. Scilab is software buy-in for the world's community. Help them with dollars, publicity, and contribute code. TTS Voices copyrighted 2014 and licensed by LinguaTech, GmbH. Visit them at linguatech.de. Text and graphics copyrighted 2019 by William Rhodes Design.